Let's go. Lesson 440 and negative exponents. So what if the exponent is 0? That little teeny tiny number is just a donut. 0. All right, well, let's explore. What is a negative exponent? Well, first off, expanded form just means write it out. All right, write out basically the definition of an exponent. All right, so it means use this 10 to the third means use 10 as a factor 3 times. Now, I will ask you just to throw a 1 in front there. Identity property says we're allowed to do that, and you can just assume that all these powers have a 1 out in front as well. So 10 times 10 times 10, right? So standard form would mean 1,000. All right. And then 10 to the second would be 1 times 10 times 10. All right, which would be 100. And then 1 times 10. And that would be just 10. Okay, so then what would 10 to the 0 be? What do you think? So we're going to use 10 as a factor 0 times. Some of you would say possibly 10 to the 0 is 0. But in our definition, and we'll see, it'll all fit together nicely. But if we keep that 1 there, then we have 1 times no 10s, right? No 10s. So then 10 to the 0 is actually going to be 1. All right, so 10 to the 0 is 1. And then if we keep going, see ya. When we continually go down, it looks like what's the pattern here? Okay, it's kind of like divide by 10, divide by 10, divide by 10. So we'll keep that pattern going, divide by 10. So this is going to actually be 1 divided by 10, or 1/10, or 0.1. Very interesting, right? All right, and then this is going to be 1 divided by 10 divided by 10, and that gives us 1 divided by 100, or 0.01. And if we continually follow this pattern, we get 1/1000, all right, or 0.001. So this tries to help us to figure out what those negative exponents mean. They don't mean that the value of the power is negative. It just simply means repeated division. So that negative exponent, it's saying repeatedly divide, but it's key that we think of it as that 1 starting us off. So 1 divided by 3/10 gives us 0.001. Okay, so what is a negative exponent? It just means repeated division. Sometimes you can think of it as it might be reciprocal as well. So why does something to the 0 power have to equal 1? Well, we can use our quotient of powers property to help us figure that out. So yeah, we can use quotient of powers to kind of back up what we think here. Why anything to the 0 has to be 1, because if we use quotient of powers rule, so let's say 10 to the 5th over 10 to the 5th. Okay, you just reason through that. It's the same number divided by itself, right? It's a number divided by itself, so that has to equal 1. Well, if we use the quotient of powers rule, all right, what's our rule? We have to subtract the exponents. So we would get 10 to the 0. So therefore, 10 to the 0 has to equal 1 if all of our rules are to kind of align and work together and not conflict or contradict each other. Okay, so anyway, just a couple of ways that we can help us. A couple things that can help us remember why this is the way it is. All right, so zero exponents and negative exponents. Let's fill the official rules in. So here it is. Boom. Pause, copy it down. That way you can kind of copy it at your own pace and process it at your own pace, and then unpause and move on. All right. Let's move on to some examples. So write each expression using a positive exponent. So we're just kind of using the definition of negative exponents, and we're going to say, well, according to this rule, right, negative exponents mean repeated division. So we're going to say, well, 1 divided by 6 3 times. Or we think, okay, well, it's the multiplicative inverse of that positive power. So if we think 6 to the third, right, what's the reciprocal or multiplicative inverse of 6 to the third? Well, that would be 1 over 6 to the third. Okay, so two ways to think about it. I like to think of it as repeated division. It just clicks for me better. So this right here doesn't make the answer negative. The answer can be negative. It just doesn't make it negative. But this means I'm going to divide by a 5 times. All right, so that's pretty simple there. Or you can think of it as, right, you can also think of it as, if you think of that positive power, it's the multiplicative inverse of that. So 1 over 5 to the 5 to the 5th. All right, you got it? All right, pause, try these, and then check your answers. There you go. All right, hopefully you did a nice job with that. You got them all right. If not, fix and try to figure out where your mistakes are. And you might have to rewind and go back and see what's going on. All right, so now we have to write each fraction as an expression using a negative exponent other than -1. So a little bit tricky, but I think we can do this. First one should be simple. This guy, we know that we're dividing there by 2 5s, right? So then we can write it with a negative exponent like that. All right, so dividing by 2 5s, we can simplify it as 5 to the -2. Now this one, you might want to, don't write this down, you might want to just go like this. Okay, well, we know that it's going to be, right, it has a 1 next to it, so we could write it as 36 to the -1, but what's the problem there? It says other than -1. We can't use -1. So what do we have to do? We have to think of some way to write 36 as a product of identical factors. So we can rewrite that as 1 over 6 times 6, and then we can say 1 over 6 squared, and that's dividing by 6 twice, so we can use the negative exponent. All right, try the guy. See if you can pull it off. All right, pause it, and then try it, and then check. Okay, so we have 1 over 8 to the third. That means we're dividing by 8 3 times, so we can rewrite that as 8 to the -3. And this one, it would be, you could do 4 to the -1, but that wouldn't follow the directions. So we're going to first write that 4 as the product of 2 identical factors of 2 times 2, which would be 1 over 2 to the second, which would give us 2 to the -2. Okay, I'm going to give you one more problem. What if I did 1 over 8? So we haven't really memorized a lot of these, but some of you might know that that's going to be 2 times 2 times 2. And then we can write that as 1 over 2 to the third, which can be written as dividing by 2 3 times. All right. Hopefully this makes sense. We're working hard and learning and figuring it out. All right, number 5. One human hair is about 1,000th inch in diameter. Write the decimal as a power of 10. Okay, so we know that that is 0.001 equals 1 over 1,000. And we know that that is 1 over 10 times 10 times 10. So that would be 1 over 10 to the third, which then we know divided by 10 3 times. So that's going to be 10 to the negative 3. Da, da, da. All right, so one human hair is about 10 to the negative 3 inches in diameter. Go ahead and try that example. What in the world? Holy moly, what? How we get all the way down to that? Okay. Let's see. A water molecule is about whatever that is, meters long. Write the decimal as a power of 10. Okay, so that's what if I do this? Okay, tenths would be 1 over 10. This would be 1 over 100. So let's see the pattern here. This would be 1 over 10 to the negative 1. This would be 1. Nope. Sorry. That'd be 10 to the negative 1. This would be 10 to the negative 2 because we basically divide by 2 tenths. This would be 1,000th. So that'd be 10 to the negative 3. So 10 to the negative 4, 10 to the negative 5, 6, 7, 8, 9, 10. So that'd be 10 to the negative 10 meters long. We could also say, okay, well, that's going to be tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths, 100 millionths, billionths, 10 billionths. Okay, so that's 1 over 10 billion. And then we can figure out how many tens that would take. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that'd be 10 tens. So it'd be 1 over 10 to the 10th, which equals that as well. So you can figure out your own method of thinking about it, but you might have a different way to think about it with your amazing number sense. But that is how you do it. And those are some maybe a little bit trickier problems. Ooh, did I totally just blitz by these guys? I did. So let's just real quick go over those. That's c to the negative 5th. And then this one would be 1 to the 3 times 3 times 3 gives me 27. And so that'd be 1 over 3 to the third, which would be 3 to the negative 3. All right, cruise in. Let's keep it moving. All right, now we're just using the rules. So negative exponents just fit into the rules just as you'd think they would. So if we're doing the power product of powers, right? We're multiplying powers. Then we keep the base and we add the exponents. So that's 3 plus negative 5, which would give us 5 to the negative 2. Because 3 plus negative 5 is negative 2. And we could rewrite that, or we could rewrite it as 1 over 5 to the second, or 1/25th. All appropriate answers for that. If it says something specifically here, like write it with a positive exponent or simplify completely, you'll know which one to do during which problems. All right. So also, it kind of makes sense, right? If we put a 1 here, and then we multiply that by 5, and then by 5, and then by 5, right, for that, 3 5s. And then we divide by 5, 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 divide by 5 5s, because it's a negative 5 there as an exponent. Well, it makes sense that we'd end up having, right, all the multiplying by 5s kind of cancel out, are canceled out by the dividing by 5s, and there's two extra dividing by 5s. So then you see there's 2 extras, or divide by 25. Okay? I know this is kind of dry, and I'm trying to pump it out because I don't want you guys to be without some teaching on Monday. All right, here we go. So we have quotient of powers, and what we're going to do here is we keep that base and we subtract the exponent. So we do the top one minus the bottom one. Oh boy, look at this. This looks fun. So now going back to our integer rules, we know that we can add the opposite. So that's -1 plus 4, and then we get w equals 3. I mean, w to the third. This, the problem, equals w to the third. And there's our answer. Whew. All right, so a lot to handle here, a lot to grasp. Let's try these practice problems, and then that will be it. All right, pause, try them, and then check out the answers afterwards. All right, no, seriously, pause and try. Don't just watch and copy it down and pretend. Try them. Try them. That's how you learn best, is if you try them and then you see how you did and learn from your mistakes if you made any. All right, here we go. Keep that base. And I'm going to take -8, and I'm going to add 2. All right, product of powers. So then I get 3 to the -6, which I could rewrite as 1 over 3 to the 6th. So I can write it as either answer. All right, now we have k, which is quotient of powers here. So we have 11. We take the top one, and we subtract the bottom exponent. And then we get 11 to the -2, or 1 over 11 to the 2nd. Next one, we got product of powers. So we're going to add the exponents, 9 plus -4. And that gives us 9 to the 5th. No need to rewrite it in any other way, although if you wanted to, 1 over n to the -5. But usually we don't go to the negatives. Usually we turn negatives into positives. Anyway, here we go. Last one. Quotient of power. So we're going to subtract the top exponent minus the bottom exponent. And make sure, right? We're subtracting and there's a negative. So you need both of those right there, subtraction and negative. And that turns it into -4 plus 7. So then we have b to the 3rd. Boom. All right, that was pretty long, but hopefully you hung in there. Good luck.